All right, so we're going to look at how to find the simplest empirical formula in this lesson. And if you recall, in the last couple of lessons, we've been working on 1 and 2 step conversions. And that's because you need to be able to understand how to go from grams to moles in order to do this calculation. So we've been learning about that. We're going to put it to a practical application here in finding the simplest empirical formula. Now, really, the empirical formula, the word empirical does mean simplest, so this is a little redundant, but sometimes they're going to call it simplest formula. Sometimes they'll call it empirical formula. Sometimes you might hear it called simplest empirical formula. But nonetheless, the way that we abbreviate this is EF. If you ever see a question that says find the EF, it wants you to find the empirical formula. The empirical formula consists of symbols of the elements in a compound and of their subscripts in their smallest whole number ratio. So some examples of an empirical formula versus what we would call a molecular formula. CO2, carbon dioxide, is an empirical formula because it's got 1 carbon and 1 oxygen in it. That's as low as those subscripts will go and still be whole numbers. But C2O4 is considered a molecular formula. This is not an empirical formula. If it can be reduced, it's not an empirical formula. Empirical means simplest. CH4 is in a 1:4 ratio. This is an empirical formula. But C4H16 is not an empirical formula. All right, so let's take a look at how we would figure out or calculate our empirical formula. First thing you want to do is you assume your percents are equal to grams. Now this is because if you were to have a sample of a substance, let's say if you were a forensic scientist and you had collected some crime scene evidence, say a white unknown powder, and you took it back to the laboratory and you analyzed it, and your analysis came back in terms of percentages of all of the elements in the compound. Well, all the percentages would have to add up to 100%. So since it's out of 100%, we can assume that that would be the same as having like 100 grams of the substance. So this is just an assumption. You assume your percents are equal to grams. Next, you want to convert your grams to moles. That's going to be a 1-step conversion. Once you get your moles, you're then going to divide by the smallest number of moles and round that answer to a whole number. These whole numbers will end up being your subscripts in your chemical formula. So since there are several steps here, really like 4 little things you have to remember, I've got a little rhyme to help you remember the steps in order of how to find an empirical formula. So you can put it in music if you want to. I'm just going to do a little rhyme here. It goes like this: percent to mass, mass to moles, divide by the smallest and round to the whole. Again, that's percent to mass, mass to moles, divide by the smallest and round to the whole. You can get a little tune if you want to. If you wanted to, put it to maybe the tune of Bad to the Bone. Percent to mass, mass to mole, divide by the smallest and round to the whole. Okay, excuse my singing there. But anyway, whatever it takes for you to remember it, these are the steps that you can follow to get your empirical formula. All right. So let's look at what an example would look like. So this first example, example 1 in your notes, says analysis of a compound shows 26.56% potassium, 35.41% chromium, and 38.03% oxygen. Find the empirical formula. These percents add up to 100%, so let's look at our first part. The first part said percent to mass, so we're going to do that first. So 26.56 grams of potassium. We have 35.41 grams of chromium. And we have 38.03 grams of oxygen. That's percent to mass. Now we're going to go mass to moles. This is our 1-step conversion. Well, we're going to do our T-chart using dimensional analysis, and of course you'll need your calculator and your periodic table. Find potassium on the periodic table. Potassium's atomic mass is 39.10, so we get 39.10 grams per mole for potassium. And That's going to give us, let's see, 26.56 divided by 39.10. We're going to get 0.6793 moles of the potassium. For chromium, if you look at it on the periodic table for chromium, you have 51.99, so 51.99 grams per mole for chromium. So we have 35.41 divided by 51.99, and that's going to give you 0.6811 for your moles of chromium. Again, same thing for oxygen, 16.00 grams per mole. So we have 38.03 divided by 16, and that's going to give you 2.377 moles. Okay, so that's mass to moles. Third step, divide by smallest. Okay, and we're going to do this at the same time. Round to the whole number. All right, so smallest number here is 0.6793. That means you're going to divide them all by 0.6793. And we're going to round this, to the whole number. It's going to give you 1 here, 1 here, and when you divide this around to the whole number, you get a 3 here. So these are our subscripts. So 1 potassium, 1 chromium, 3 oxygen. So your empirical formula, which is what you're trying to get to, is K1Cr1O3. Of course, you would not have to write the ones, but just for the purpose of looking back at our answers here. All right, let's look at one more example. A compound, diborane, is found to contain 78% boron and 22% hydrogen. Find its empirical formula. So, percent to mass, 78 grams of boron, 22 grams of hydrogen. Okay, so we need grams on bottom for boron. If you look on the periodic table, he's 10.81. So that's 78 divided by 10.81, and that's going to give you 7.2 moles for that. And for the hydrogen, 1.01 grams per mole for the hydrogen. So 22 divided by 1.01 is going to give you 22 right back. Okay. So divide by the smallest, 7.2, 7.2, and round to the whole. You get a 1 here and a 3 here. That means your empirical formula is BH3, and that is your answer. All right. Next class, we'll learn how to find the molecular formula, kind of piggybacking on this concept. Your homework tonight is going to have a little bit of this on it too.